Hello everyone, I am İsmail Mertkan and co-authors are Tuğçe Tezel and Volkan Kovan. Today I'm going to present you an overview of hybrid manufacturing of plastics. The additive manufacturing method, which emerged with the stereolithography type in the 1980s, was developed and many different sub-branches were derived as a result of the research. The production of the new method, also known as rapid prototyping, is based on the principle of adding layers and fabricating directly to the desired part. Shareable and accessible 3D digital designs created for AM use led to the refinement of models and the vast design library on the internet. The distinct difference between AM and subtractive manufacturing due to the ability to produce without chip formation also entails different advantages and disadvantages. Although this technology was initially used to produce low-cost prototypes, original or replacement products can be produced thanks to the newly available material that have emerged due to today's work. AM advantages include the ability to produce parts directly into complex shapes, the absence of time, energy, and material waste due to chip formation, low cost for a small number of production, easy control of machines, assembly of parts, and rapid production. The disadvantage of AM compared to the other methods can be shown as poor surface quality, high cost mass production, low mechanical properties due to anisotropic behavior, limitation of part size due to truss bed size, post-production processes. These advantages enable this method to be preferred in many sectors, such as automotive, medicine, building, education, architecture, and aviation. Subtractive manufacturing is a traditional production method that has been widely used in the industries for many years. Small parts are cut from the surface of the workpiece with the help of a milling cutter or machining to achieve the desired shape and surface level. Precision tolerance, dimensional accuracy, low-cost production for mass production, and good mechanical properties are advantages, and chip formation, production, difficulty for parts with complex geometries, disadvantages of the SM method. Purpose of the study. The advantage of machining to achieve the desired shape and surface quality in manufacturing combined with the production of complex geometry offered by AM has revealed the need for hybrid production. Thus, with the aim of a higher quality production process, the literature on the use of hybrid production in plastics is reviewed in this study. Hybrid manufacturing. Research have been made as to the more detailed, fast, and intelligent production requirement of the new industrial age, and as a result, a new fabrication method has emerged. One of these production methods is hybrid production, which has emerged due to research. HM is a production method that combines the advantages of two different production methods. This technology has been used in the last decade and continues to be developed for better production processes. As can be seen in AM and SM methods' advantages and disadvantages, no production method can solve all production problems. It aims to use the advantages of combined methods in the HM production processes and eliminate the disadvantages. So HM offers convenience for industries with this application. Since HM is formed by combining different production methods, it is possible to talk about different HM types. There are casting and SM, injection molding and SM, additive manufacturing and SM respectively. Casting is a production method commonly used in industries and allows the production of stuff with complicated shapes depending on the mold design, Naturally, unwanted features such as low surface quality and shrinkage caused by the molding surface or sand roughness also appear in the casting method. Milling post-processing is necessary after the casting process in order to obtain precise tolerances. Injection molding is another production method that has been used in the industry for many years and allows the use of different material options. The mold that designs the shape of the part must be designed correctly. Cost increases in direct proportion to the complexity of the mold design, and post-processing may be required after injection molding to improve the surface. For this reason, hybrid production can be realized by using injection molding and subtractive manufacturing together. AM and SM combined is the most well-known method among the HM methods. Thanks to AM method, the production of various materials like metal, polymers, composites, and ceramics, which emerge with research, can be used without the necessity of mold, unlike casting and injection molding. In addition to these profits, cost, time, and energy, which are significant production factors, do not waste what is caused by mold design and fabrication. As described before, the exceed surface roughness, unprecise tolerances, and dimensional deviations brought by AM are unwanted drawbacks that induce harmful mechanical properties that can be eliminated with SM. As the talent of AM, material addition to existing part is possible, which also can be improved by AM. Hybrid manufacturing also has various usage areas such as coating and repair. The material added to existing parts and repair broken or damaged parts makes HM find a usage field in repair applications. The part which repaired and added to the existing one also can be milled with the SM method and can be raised to desired surface quality. In this way, the cost borne of producing whole part can be removable and ensure to save time, material, and energy. Where heat resistance or strength is required in the manufacture of stuff, these materials can be used only where necessary. After that, another material can be used for the remainder of the part, or the base material can be covered with materials that have particular properties under the favor of usage of distinct materials in a single part with the HM method. Literature review. Optimization of the FDM and HM method using machining was investigated by Grobrus and Kramer. For this, different nozzle sizes and various production parameters at 3 different levels have been selected for the optimization process. Polylactic acid, material usage, production time, and surface roughness parameters are investigated and analyzed as optimization criteria. As a result of study, it was determined that the large size nozzle produced the desired part in a shorter time than the small size nozzle. Surface roughness results are almost the same in small and large nozzles due to the milling process. Thus, the quality of the parts produced by HM with large size nozzles can be produced with low-cost production, less time, and better surface quality than the normal FDM production process. Lee et al. Used an HM method that combines FDM and milling to study a 6-axis design for PLA material. The FDM extruder and cutting tool performing the production is designed to be removable and interchangeable to fulfill their tasks. The study concluded that the production capacity increased thanks to the 6-axis design. The latter effect brought by the AM method was eliminated with SM, and the improved surface was obtained in a short time. Lee et al. Developed a different design for HM using FDM and CNC machining combinations for hybrid production. An acrylonitrile butadiene styrene material was used in this design. Unlike the ordinary FDM system, the production capacity has increased to produce 5 axes for the new designed HM, with the new axis definition to the extruder and milling plate, and to produce improved parts. In this way, the new design allows the FDM and the milling head to switch between each other and produce at different angles by rotating the axis. In the study, new design with embedded parts with the SM method showed that the ability to print at the desired level of a part without support material, parts with curved surface, parts with surface quality was obtained, and the ladder effect caused by layers caused by AM disappeared. Besides, it was concluded that the production time was shortened by 44% compared to ordinary methods. Boschetto et al. Examined the effect of cutting depth during finishing operations with fabrication factors for acrylonitrile styrene material. Experiments have shown that the cut depth should depend on the deposition angle of a part produced by AM. As a result, a reduction in surface roughness has been achieved. Stereo condition is a significant undesirable effect caused by surface roughness as a result of the AM method. Tezel compared the SM and FDM combination of the HM method in polyamide hollows, which are widely used in engineering. In the investigation of a hole quality produced by casting and AM methods, the manufacturing quality is improved by drilling and reaming. SM-type methods were compared. At the end of the production process with different parameters, it was seen that the hole produced by three-dimensional methods needs a finishing process. It has been shown that the quality of the hole produced by the three-dimensional method is better after the SM process compared to the casting method. As a result of theoretical and experimental studies, it was suggested by Boschetto and Bottini that the surface quality of specimens which fabricated with ABS can be improved. Conclusion: the hybrid manufacturing method is a reasonably new production method with high production capabilities, different types, and development. Leading brands of the industry and world-renowned brands make improvement on this production method and produce devices. While HM methods are mainly used to use metal materials, plastics are also used with the HM method, and studies are carried out in this area. Studies have shown that plastics hybrid manufacturing provides benefits in critical production parameters, such as time, cost, and energy. HM provides users with significant ease of use and advantages by offering additive manufacturing, subtractive, and hybrid manufacturing. Besides these essential benefits, it should be carefully selected which method will be used during material production, and tool collision problems should be considered. It is thought that the HM method can be used in various applications in the use of both plastics and metal materials and is a promising method. Here are my references. Thank you for listening.